Hello everyone, I want to welcome you to my YouTube channel. This is Steve coming back with another video for the tutorial series. This is tutorial, 6 already? And I've got a few different things I'm going to go over here for you today. Before I do that, I wanted to show you some of the other things I'm kind of working on right now. I've been thinking about, since, I've been kind of sticking around with the Commodore 64 lately, and just seeing a rise in the trend of 8-bit stuff. I've been thinking about creating another channel just to showcase a lot of the 8-bit games, or the games that were done back in the 80s and even in the 90s, basically the classic games. And one of them, the languages I've showed on here before, which I've used intensively, is known as Qbasic. Now, I got into Qbasic, just kind of a short synopsis on that. I got into Qbasic shortly after I had actually stopped, doing stuff on the Commodore 64 and stuff like that. And I started writing programs back in the 90s, and eventually I decided that I was going to try something different. I think probably by the time I got into college around 94 and taking up programming courses is when I decided I was going to try something different and discovered some of the languages that Microsoft had out there and came across Qbasic. So let me kind of just go back to short screen here. Got to position myself there. And just to show you, this is one, I'm going to put this on another channel, but this is going to be one of the things, and this is actually you've seen this probably on my website before, and I created that Java game very similar. This is the original Mazes of Misery kind of stuff that I was into back in the days. I liked just creating, fun stuff. And this one actually has 64 different screens on it. So the whole trick of this game too is, in order to open every door you see on that screen, you have to find that key. So only this key alone can open that door. So it's kind of tricky because the mazes are all set up, and you kind of figure out which key goes to what, and very challenging. There's actually 64 screens in total, and yeah, so this key I just picked up, it just tells you that you have found a key and it only opens the door in this room. So only this key is going to operate this door alone. So that's the whole point of the game here. So I'm not going to spend a lot of time on it. I just wanted to show you that's kind of something I was working on for a good time there. So animations built in, you see the little spiders, even though this is very simple graphics, I was told. Yeah. So anyways, I'll show you the language, and that's going to, oh, also if you hit the escape key, there's kind of a little optional thing you can see with the game itself. You can abort it. You can speed up the game here by hitting this one. You use this little arrow here, and you move this backward and forward, and this controls it's basically a for loop in a game, but you'll see it makes them faster, but it was never a true control of the game itself. So anyway, this is the language, and this is actually Qbasic. This is the actual program you just saw on the screen there. If you're interested in seeing this on GitHub, let me know. I'll throw it out in GitHub for people. Qbasic is not very common on YouTube, although back in the days in the 90s it was very popular. So anyways, let's get into the actual video. So we can move on here. And this is actually my notes, which I will be going over here today. So I'm going to put these on the other screen so I can kind of see them. And we'll move Vice over here to get started. And as always, I'm going to go back over what we previously reviewed in the last video, for those who didn't catch it or want to see it. So after I introduced the other stuff, we went over the get statement. And let me just introduce a simple get statement. So we'll throw a message on. Actually, let's clear the screen first. This is just my own program. You make this a question mark too, remember? We'll just say press space to see a message. And this next line is what controls the get statement. We'll separate that. And then we're going to freeze get until we get a key. Oops. You have to freeze it like this, or otherwise it won't know where to go. And then now you control it. Now, I've used this before to show you you can put a character inside of here or whatever. I'm going to show you another trick real quick here. You've seen this before. You can use Chr String. The $ represents a string, remember. And 32 is the space character held for the space key. So it says to press space to see a message. So if you use the 32, then it's going to show a message. And then we can go to 70. 60 is going to go back to 30 since we haven't pressed a key yet. And then we'll print the message. You did great or whatever. So let's run it and test it. So press space to see a message. Now you press any other keys other than space, it's just going to remain frozen and basically not do anything. You press the space bar and it's going to give you a little message. So pretty essential and pretty simple. We also showed the stop key, so we could also make it just go down to line 80 and stop instead of just going back to the ready prompt. And I'm going to put a message after this to show you something else here in a minute. So press space to see message. You did great, and you'll see it breaks in line 80. That's what stop does, is it allows you to break in a line. Stop is, I also didn't mention, but stop is used for good debugging purposes. If you have an error in a program and you can't figure out maybe there's a variable not doing a right calculation or something doesn't look positioned right on your screen, whatever the situation may be, stop is a great way to kind of put that in your program to see what's going on. Now in the semi language, this is known as BRK or break, but this isn't a semi language video, but for those who are curious, that's basically the same thing. Now what we're going to do is after we stop the program, I'm going to introduce, just show you the other one, it's continue. So as you press space, you see it stops, and if I type CONT, it continues to the next line to print the next message, which was continue right there. Okay, so I should get in the habit of saving these on the screen now. I forgot to set my disk here too. I'm going to pause here a second so you don't have to go through all this. Okay, so I just basically went up here and I attached it to a file that I had set in GitHub here, and it's called C64 very basic.d64. And you just hit attach there once you clicked on it, and it attaches and allows you to save your little program. And actually, you know what? We don't need to save this one anyway. These I don't save the demos that are explained in the previous instructions. I explain the ones going forward. If you want me to start doing, I can, but I mean, pretty much this is kind of repeat. I mean, since this one's a little bit different, I think we'll save this one. And actually, let me go back and check what was this called real quick. I didn't want to override another one, so I don't have any gets on here, so I think we could probably throw the get in here. I get example 1 and 2.5 there. So we'll save the get on this one. And this is a get example 3 or whatever you want to call it. And then we just do the point after it. So that represents tutorial 6. And I just put the date in. And so forth. And you just save it as get example 3.6. So this is get example. Well, actually, for this video, it's 1 because this is the first example for 1.6. So we have to set this to 1. So it represents the first get example 1, and then tutorial 6. Like so. Okay, so the next thing we're going to do is just go over the read examples here that I had demonstrated before. So we can do this. You always want to start with a fresh program. And we learned about the read statement, so we'll set a for loop to read some data on the screen. I'll show you how to print a message in text characters. I may or may not show this before, so I'm going to do it. We're going to read a string. We can just call it S for string. And as we read it, we're just going to print. Actually, this might be a little fast if I go this way, so we'll avoid that for now, I guess. And what we're going to do is we're going to print a message on the screen. I'm just going to cheat and look up in my book here so I can surprise you with a simple little message. Just looking at the character set, which I thought was in here. Time to pause again. Okay, so I'm going to run this little simple program here. I changed it a little bit here. Basically, it prints a message, and now it doesn't have any spaces in it because you can't put spaces in here. But later down the road, we'll learn how to convert and put spaces in here and stuff like that. So for now, I just wanted to show you, basically it reads 1 to 5, reads the S string, which is the loop there. I'm sorry, the string, and it prints a string on the screen there. You can also make it do numbers. So we'll just change this to numbers. Just go here and change this to like an S. And just take out the dollar signs and you can get the numbers. And we're going to put in 5 different numbers. Sounds good, I guess. And whoops, what did I do wrong? Oh, I left the dollar sign in there. So now it'll read the numbers. And there's our numbers. So we also learned about the arrays, and that's basically storing the numbers, so we could make it just say read S, A, like that. And we won't print them out this time, but I'll show you what I'm going to do here. Oh, and let me clear the screen before I forget, so it doesn't get so messy. So there's no values, right? You don't see any values, but... Oh, I forgot the Commodore 64 doesn't remember unless you stop. So what we do is we'll print them right after the next statement here. So after the next is done here, it doesn't seem there's any more data, but there will be more data in the memory because we'll be able to print them out here. I'm just going to skip a line there. So we'll just read through the loop, and we'll print them out as we read them in. Oops, I made an error there. And there they are. So see, we read them in here first, and then after we have the memory stored in the arrays, we can print them out to the screen. Now if I try to print them like this, it's not gonna. Actually, it does remember them. That's right. I thought it cleared them, but it started at 1. That's why I didn't. Earlier you saw me do S0. Unless I changed this to 0, you would never have seen the 0. That's why it didn't work earlier. Run it again. There's the numbers. Now if I print S0, you'll see the first number. Okay, so those are simple arrays, and I think that is it. I think we can safely move on to the next statements here. And then we saw an example of the Powerball and stuff like that. So, getting into this session, and I'm kind of pressing myself up against a wall here. I'm also supposed to meet with somebody on Skype here, so I'm going to try to make this work one way or the other here. Let me go ahead and get my example up here. So now we're going to be learning about basically something called dimensioning arrays. And let me go ahead and type the program in here. We'll erase this one. And we'll type in a new one here. Clear the screen. I'm just going to run it so I can clear the screen there. And let's type it in. Oops, I skipped something here. 60. Oh, there is no 60. Oh, how weird. I need to change my program here. wondering why that looked funny. I actually originally skipped a line there in the original program, but we'll fix that. I'll pause here a second. Try lost my place here. Actually, I just found it. Okay. This is kind of a long program here, so I'm making sure I'm typing it in right. So this actually has 2 lines on it. It goes down twice. See, 100, 110. I think they skipped a line in the program. Let me just double check my work again. Sorry for that, guys. I had to go back and change some of my lines there. I originally wrote them down wrong, so I had to pull the book back up and make sure I was typing them in right and edit out the mistakes there. So I love that pause button. Now it begins all the data statements. I think we'll just run it first. Hopefully it works. You know, syntax error. Oh. Need to have the variable. It doesn't know which one you're dimensioning. It should be good now. And what it does is it's a delayed loop, and it's showing you all the numbers that it's pulling from the data in sections there. That's all the data that it defined. Kind of cool. So let's go over that. Now, you notice how it scrolls off the top of the screen. To show you a trick to this, you can hold down the tab key and it'll slow down the listing, and when you get toward the top there, you can press the escape key to kind of break out of the listing. So we know line 5 is clearing the screen. Line 10 is doing something new. It's called dimensioning double dimensioned array. They're called, yeah, double dimensioned array, I believe that's the name of them. And what we're doing is we're setting it for the row, so it's 10 rows by 5 columns. And let me demonstrate with my low example here. I'll blow this up a little bit so you can see it. and open it a little bit. So let's put this over here for a minute so I can demonstrate what's going on. So what we have here is these are the rows. The rows are going down the screen, and everything going over to the right here, these are the columns. Okay, so the first thing we're doing is we're going to read from R equals 1 to 10. So basically what it's doing is it's reading straight down the screen here from 1, 2, 3, 4, all the way up to 10. And that's this first number here. So it's going to basically start reading here and reading from 1 to 10. Now if we need to run it again here, you can see the first one. I'll break out the first one there. It says 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. So if you look on the screen here, and it shows you, oh actually, yeah, I'm sorry, 1, 3, 5, 7, 9. I'm just going to highlight these so I know which ones I'm talking about here, so I don't get that mixed up. Okay, because this is just numbered rows. I just numbered the table there. So the 1, 3, 5, 7, 9 is the first part we read for the R, and let me put that back on the screen here. So we read the first row, so it's taking care of the first part of the array. Now we're going to just set a variable of t equal to 0 so that we can reset our totals there. Because what it's doing is it's getting averages. This is averaging by the total of the rows because there's 5 columns there. And then next we're going to say for c equals 1 to 5, c representing columns, I guess, from what they put here. So the columns are actually going across here. So I think I did this backwards. The rows, yeah, the rows are going down here, so it's going down the screen. So basically each row is taking care of this. So really what this R is doing is it's taking this first one, storing it into memory. So if we print it out on the screen here, hopefully it'll work here. Let's just print out, what is that, 1, 0. Oh, yeah, no, because they started at 1, that's right. So it'll be 1, 1. And again, is that the array? Oh, it's A, I'm sorry. X. What am I doing here? There we are. Getting myself messed up here. So X. So X represents the first one of our R. Now notice here at the screen, I'll have to put it back on the screen here because it went off the screen again. Right there. Notice that it's reading for R equals 1 to 10 the first time. Now I've showed this before. You see another 4 down here, but you don't see a next in between here. You don't see a next until down here. So this next C is always keeping track of what C is doing. So they always have to stay together like this. They always have to be close together. You can't have a 4C equals 1 and then down here I have a next R because it'll be out of the loop. So what you always want to do is you want to follow them in order like that, keep them conditioned, and then you go to the outside. So you work from the inner first, and then you work from the outer last. Hopefully that makes sense to you. So what we're going to do is we're reading the first value of R. We're not going straight to 2 when we get here because we haven't reached R yet. Now we're going to increment through C to get the next value, which is 1. And that's what you saw me print earlier down on the screen here. Now I think I'll print it down here because it went off the screen last time. X 1, 1 to get the 1, 1 to get the first row of the data, which is this one right here. Now to get this 3, what we're going to do is we're going to pay attention. Now we went to C, and we know C is, right. If you look right here, it also shows you R is the first value there, R, and then C is the second value. So to get to the next value, we have to increment the next R. So this should work if I put this at 2, I believe. Actually, I did that backwards, so my bad. So that's right, because R is only changing the row when we get to the end. We're still in the column, so C is the column, excuse me. This would be 2, and there's our 3. See how it works? So we got 1, 1. I'll put them like this. And 1, 2, so you can see them. And then we'll do the same thing next. We're just going to keep increasing that column till we reach the end. Or, yeah, keep reaching that column till we reach the end of it. And you see how it's printing these on the screen as I'm going through here, just like on our chart over here, 1, 3, 5. This is a way to set up, you could set this up for a lot of different examples in games, like rolling numbers and keeping track of, you know, scores, and you could keep track of statistics. That's a good one for games. And then I'll put the 5 on here. It's probably going to go off the screen here, but I'll put it on here. Hopefully it doesn't. Yeah, it went off the screen. It went on the next line there. So we got our 1, 3, 5, 7, 9. If you look over here, 1, 3, 5, 7, 9. So we're in the first column. We haven't done anything with the next row yet. This one's going to increase next, and we're going to basically reset this one back to 1, since that's what our column is going to do. It's going to reset the column back, and it's going to start with the next row. Now, if you pay attention here, what we said earlier, remember, we're still in this line, C equals 1 to 5. So we're basically going through each of these. So this is C equals 1, C equals 2, I'm sorry, C equals 1, C equals 2, C equals 3, C equals 4, C equals 5. I'll put it down here again so people kind of don't get lost on that. So C equals 1, what is that, like this, I guess. C equals 1, to show you that that represents this one. How about we do it this way? R equals 1, C equals 1. So that's just basically showing you this is the first part of this R, keeping track of what the R was doing. It went off the screen here again. But you remember, it went from R equals 1 to 10. As we see over here already. And this next one is going to go like this. We'll just put it beside it, I guess. R equals 1, so we're still staying at 1 again. Now C is going to be equal to 2, since we're now in this one. Remember, R is not changing. That's the first array of the 4. This is the 4R equals. This is the 4C equals. So R equals 1. It stays the same, and now column is changed because we're moved over here to the second one. So now column is equal to 2, so the column is going to change, but R is not changed yet because we haven't incremented back to that for loop yet. So now we're going to say R equals 1 again, C equals 3. Now once again, our R has not changed because we're still on the same R. We went for R equals 1 to 10. We have not come back and came back to that loop again here, so we're still in that same loop. But our column is changed over the 3 here, since you can see right here, this is inside the same loop, so it's basically incrementing all this data. And this readx is just reading these values into memory. It's not reading 2. You see 2 different values here, so don't get confused by that. It's only reading 1 at a time, but it's reading them in dimensions. So this is going from left to right, and this would be the columns, and it's going down, and this is the rows going down. So we won't see this 2 until we finish our complete column. So down here we got C equals 3, and then of course we have R equals 1, C equals 4, and then R equals 1, C equals 5, like that. So we got all our columns. Now remember, look, now once again, just pay attention and to reiterate here, or to go back over this, R equals 1 does not change, and none of these R's are changing. They're always going to show the same one because we're still in this first row right here. We're still in this first row, like that. However, we're in a different column, so the column is incrementing each time. So if I can put it up here to show it to you easier too, this is not make this too confusing for people. C equals 1. This is R, and I'm sorry, this is R because it's all in the same row. And this C equals 1, C equals 2, C equals 3, C equals 4, C equals 5. And that's essentially what these rows are doing up here. So if I had to put this in here, I'd just say this is C equals 1, C equals 2, C equals 3, C equals 4, and C equals, C equals 5. So hopefully that makes more sense. And then this is the row going down the screen. This is R. It's going to do that unless I really go back and change it. It always wants to format it. And this is R equals 1. It'll take me a while to get used to these keys because they reverse on the advice. R equals 2. R equals 3. R equals 4. I think you're getting the hang. I hope you're getting the idea of this. This is why I wanted to simplify this for people, because it's a very basic tutorial. R equals 6. R equals 7. R equals 8. Just going to try to format my number again. R equals 9. And then we got R equals 10. Oops. 10. So I change the size of these. Like so. So there you go. So hopefully that makes sense. Now you can see these are just the rows, and just like we saw here, we're in the first row of this one. So we've never incremented this one. It's always staying here until we finish out our loop. Think of this as the R still going through because we haven't incremented. And then we're still incrementing C, so it's incrementing the second parameter we see of the array right here. So that's going to keep increasing. Now how do we get to the next row? It should already be obvious, but if it's not, I'll show you. I'm just going to go ahead and erase these just for purposes. Now pretend we're in the next row, and we're going to leave our columns the way they are, but I'm going to erase all these just to show you one by one again here. I'm also going to go down here. I'm going to erase these. I only do it once so that it's not, or do it twice so that we don't have to keep doing it for every single one, but I wanted you to get the idea of how these dimensions work, because it can be sometimes kind of hard to wrap this stuff around your head if you're not seeing it. I like to see things visual myself, so hopefully this helps. So now we are incrementing to the second value, and we're staying at the 1, or sorry, we're staying at the 1 because we're still in the first column, but we're on the second row. So now if I hit enter here, you'll see the 2, which is our next value down here. Now we go back and change this one. And remember, we're just going to keep the R at the same again because we're going to go straight through that row. We're not changing row 2 until we finish the columns. 2. Oops. Not sure why that one came out like that. Oh, I put an R in there. My bad. That array didn't exist, so make sure to use the same array name, which is X. And then again, we're staying at 2, but we're changing to 3. And you see that corresponds to this, 2, 4, 6. Now we do the next one. We're staying in row 2, and we're in column 4 now for row 2. And you see that's the 8, as seen up here, 2, 4, 6, 8. And then this one's going to go down on the next line, since we only have 40, or what is it, 20, whatever, per line there. Then we're going to go to the next one, which is 5. And you see that's the 8. And then we have one more to go, of course. So we're going to have to print another line down here and insert this down a little bit here. Let's see, 1, 2, 3, 4, 5. No, I think I got everything. I'm not sure why I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, that's right. That's right. They're all there. 2, 4, 6, 8, 10. 2, 4, 6, 8, and 10. So hopefully that makes more sense a little bit. And then once we've gone through and we've read all of these rows and columns, we're now going to do our totals. If you remember before, the t equals t plus x. It's taking all these and it's totaling them together to get an average of each row. So if I show you down here, remember t started with 0 here on line 30. But now we could use, we'll just use a different example. Actually, let's just reset it here to make it easier for people to understand. And then we'll just use this one to increment it. So now t is equal to 0, but we're going to increment our values here one by one. We're going to do it without the for loop. Let's see if I can do it without the for loop here. But what we have to do is we're going to do the the second row, not the first row. We'll get the average of the second row. And it's already on the screen there, so if you see it there, you'll notice it's already on the screen. So essentially, you can do it like this. This is what the computer's doing anyway. Just getting those totals right across the screen there. That's exactly how that T would look if you saw it and broke it down line by line. Let me just double check my work. 2, 2, 2, 3, 2, 4, 2, 5. And then, oh, I forgot to put the X value in. I keep forgetting that. So you make sure to always include the letter, or it doesn't know what the array is. It'll just give you an error, say, I don't understand. You always have to include that array value in there, or the subscript there. There we go. And to make sure I did this right, I'm going to reset T again, because earlier just to make sure nothing goes wrong here. So we'll set it to that, and I got an error again. Why did I get an error? Oh, because you can't use commas in these, you got to use pluses. So I'm making all kinds of errors here because I'm kind of in a hurry. I'm supposed to meet up with somebody here. So anyways, we'll set this like this. Now we have a value for T, which is 32. And to test that, we're going to add those numbers together, which I don't think that's right, but let's reset this to 0 just to be sure. Let's see, 2, 1, 2, 2. Oh, that would be right. We're in the second row, so it would be 32. Okay, so let's go down here and we'll print them, and I'll show you what it did here. Oh. Let's calculate them again, and wants to go down that line every time. And we'll print T. I'm trying to stay on the same screen as 30 there. And now we're going to say, get the totals here. We're going to print all those values together and show you where the calculation came from. And it's the same thing that the subscript array just did for you. And actually, I missed a value or something. What did I do here? 2, 4, 6, 8, 10. Oh, that's right, because it's 30, yeah. So that's right. So it gets the total of all of those. And then if you look at the next value here, which is off the screen again, but it was divided by 5. I could show you down here in the program. I have it on here too. Probably easier way to explain this. Let's see. The total is right here. So we're on this line right here. So what it's doing is it's taking AR of each row there. So AR, it's not doing AR comma C because it's only doing the first row of that calculation instead of doing all the columns. It's just the way the formula is going to work here easier, because this AR is outside of this C loop, so it's basically calculating off of the rows each time there. And then if you take 30 divided by 5, you get 6. So the average of these numbers is 6, what it's essentially saying here. Which I don't know if that's what the program was doing. I wanted to kind of double check it. It's 5. So it's, oh, I see. It's not actually doing. So I did it differently. I just calculated it across here. But what it, no, that was right. It did the first row. Let me just double check this again. I have to stop at the second one here. So 2, 4, 6, 8, 10. Yeah, average is 6. I was right. I was doing the second row, not the first one. But it printed the first one because it shows all the rows there. Okay, so hopefully that makes sense. I know we spent a lot of time on it. These are a little bit more complicated, so I needed to use a little bit more time. Of course, I introduced the Qbasic stuff at the beginning there. So it's kind of part of my promotion that I do here. So I didn't realize this one was going to take this long. I don't want to make these videos super long, but let's see if we can try to come up with maybe just a short program for this or whatever. Because arrays these kind of things can kind of be hard to wrap your head around. This is why I didn't want to spend, you know, a lot of time going right into another example and try to, because these are a little bit more complex than any other code you might come across. To be honest with you, myself, it took me a little bit of time to try to get used to them. So I prefer if we would just take our time with this one and then we just come up with a little example like we did before using them or something like that. So let's finish this one off. So we've got the totals right here, and we completed our R since we've gone in iterations of R there. And then after that now, we're going to use the R. We're using R again here. So you notice here it says next R, and you see for R equals 1 to 10. It's just reusing R again. it's resetting R back to 1, because anytime you use a 4 with that same R after you finish the last R, it's just resetting that one back again. And this one's going to print the rows here, so it's basically tallying up all the data of all these rows first and getting the averages of all of these columns as it's going across each one there and divide them by 5, since there's 5 in a row there. And then it's going to print all the rows here, so it's saying for R equals 1 to 10, remember 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 going down, and the columns 1, 2, 3, 4, 5, always going across. It's going to say the row, so it's going to print this row right here, and it's going to keep track of the R, and in here it's going to say the column for C, 1, 2, 3, 4, 5, we know going across, so we've seen our regular X, R, comma, C, and we keep it within our same loop of C. This one's kind of, using our colon to keep them on the same line where this one separated them. And then once we get that first column, then we're going to print a message inside of our loop as we're calculating. It's going to say the average is equal to A of R. Remember, A of R is just keeping track of this whole row right here. So it's basically going to say, what is the average of this whole row? That's how this AR works. And this for D equals 1 to 1000 next. I don't know if I showed this before. This is a way to slow down your loop. So notice there's no print or anything in between here. If you just set a 4 and a next together like that, it'll slow down an alteration. That's why you've seen it pause as it went down the screen there. And then of course now once we paused on the first line and we printed our totals, we can come to the next R and we can increase this one back to 2 to get the next row, 3, 4, 5, and so on until we finish it. So let's run it one more time. And I'll have to put together a program for this. There's a second one. There's a third one. And you see the averages is keeping track of them each time. There's the fourth. There's the fifth, the average of that, and so on, until it finishes them. Okay, so it's time to pause, and I'm going to see if I can come up with a little example here for you. Okay, everyone, I'm back. Actually, it took me longer than I thought to create this, but here's the example. I think you should enjoy this. It's actually a simple map that it creates on the screen as if you were like playing a game or something. So let me just run it first to demonstrate it, and you'll see what I kind of put into it. Simple game map, and it shows the game map as it's printing each of the arrays. Remember, the rows are going down and the columns are going over. So this time we have more columns. We have 12 columns going to the, well, we have 12 columns going to the right there, and then we have the rows of 12 columns to kind of make a map. It's a smaller map, but you can see what it does here is it points out the map contains 7 places where the letter A is found. And basically you count them 1, 2, 3, 4, 5, 6, 7. It basically strategically figures out using the condition statement where each of the letters are located. So let me show you that in the actual program here. So got to do this quickly. So print, let's clear the screen. T1, this is the tab space for 12. So this is going to basically allow our tab down here to move over 12. That sets our map toward the center of the screen. And then TT equals 0, that's the totals. That's the total of these 6 letter A's that we found in the map. CO equals 155. Now this is a color change. If you remember the Chr string, it's going to basically, in I think one of either tutorial 1 or 2, I explained how you can change color using CHRs. So that's what that's doing, is basically changing the color of brown so that our map starts as brown. And then that's actually contained down here. We'll get to there in a minute. These are just setting their variables up first. And as we saw earlier, now we set up a multi-dimension, and they're called multi-dimension arrays, by the way, multi-dimension array, to have it 12 rows, as I explained, and 12 rows by 12 columns. And we're going to figure out, first of all, we're going to figure out what the row is. So there's 12 rows, so going down there's 12 rows, and then 12 rows going over, 12 columns going over. So X, think of X as going a column, and Y is the row. And that's common in basic programming. And then you're going to read in the rows just like before. Nothing's different here. We're just reading the data, which you'll see the data on here in a minute. And then we're setting the next X to keep track of the X. We always want to stay within the same X. So we don't want to start this with X equals 1 and set next Y, because that'll throw off this X. So always keep them together like that. And then this is called the inner and the outer loops. The inner loop is X and the outer loop is Y. So that completes the map. And it prints the message we saw on the screen. It moves the arrow down twice, so those are the special or the PAXI characters to move the cursor down the screen twice, and it changes it for the letter brown to print the white to say a simple game map. And then this is just doing the same thing up here. So earlier we read the data, and now we're going to read it. Now we're going to produce it on the screen. So we're just going to reuse our y equals 12, which is our row, and then x is our column, 12. Now this is what you're going to have to take a look at. So before I show you this line, I'll probably need to explain the other line. What this is doing is it's looking for the letter 65 in our map. And if it finds the letter 65, which is a character code for the letter A, I didn't have it up here fast enough to show it to you, but it's actually in the character set. It finds the letter A. When it finds the letter A on the screen, it's able to go ahead and instantly say that that's the letter A. We found the letter A, so we're going to increase it by a total here, and we're going to change the color to white, so it prints that character white on the screen. So this first one here says NPY, X greater or less than 65. This means that there's no letter A found. Then keep the color the same color as the map, which is brown. So this one's down here. Let me just go down here to show you the rest. This one is saying after this prints it on the screen. Now this one might throw you off a little bit here and run a little bit over here. It's going to print the map starting with the first character you saw on the screen earlier at the T1, which is our position for 12, our tab 12. So it's going to move it over 12. And this is going to change the color. Remember, the color is only going to change when we see the letter A. If we see the letter A, it's going to change to white. Otherwise, it's going to be brown. So that keeps track of the color change. And this is a simple way of taking a character that's already a number, which you'll see down here in the data, and translating it into a Chr string, or basically a pet axis, so that we can see the actual characters instead of just seeing the numbers on the screen. Because the data's got all numbers in it, which you'll see down here in a minute. And this just prints them from left to right following the y. So y equals 1 to 12. Remember, that's the row. It's just printing the row going down. So this first one's not going to change until we complete this inner loop, which is our column, which is what our x I explained earlier in the other program. And then we're going to say if the value of x, which is our row, as we're moving over the screen each time we're scanning, is greater than 11. So as soon as we finish the first row, we know greater 11 would be 12. That would be 12 columns. Then we're going to set a print statement so we can jump down the screen. Otherwise, it'll just print all the data going on the screen, and it won't look like a map. It'll just look like a giant line. And this next one, C equals 155. Actually, I don't need this one. Let me take out 107. I originally had it, but I don't need it. It'll still do the same thing without it. Yeah, it still does the same thing. So let's go back to 107, and you can start seeing some of the data now. Went too far. So use your tab to pause again, remember. Hold it down, and then press the escape key to break out. And then so we're saying 107 is gone, so we don't need that since we already earlier changed the color here. So if we're greater than 11, we know we're going to print, and then we're just going to follow the next X to keep track of 12. Remember this row going down here? This is the row, and these are the columns, just like I showed earlier. And then it's going to print at the very end once it's done, and after it finishes the next X and the next Y, it's going to print the map contains TT. That was the total. Remember, we were keeping track of the total. Every time we find a 65, it's going to say it contains the total places where the letter A is found. So it keeps track of the total because it's accumulating this as it's going through this data here. And let me show you that. So we already know how this works from left to right. You notice I have a 35 on your screen. You'll be like, huh? I don't see a 35. I see, I see characters on the screen. Where's the 35? Well, that's what this line does right here, is it basically translates that 35 into a character. And let me demonstrate that real quick here by giving you an example. So if we print 65, we're going to have a 65. But if we hit Chr string 65 after it, we're going to get the letter A. So that's how it translates each of these on the screen. So if we hit 35 here, we get this, and we translate it here, you'll remember that number sign, which is for the map. And then if you look through the data here, you'll see different characters like 77, and then you'll see all the data here. And it's basically 12 columns by 12 rows, so I'll show you all the data there. And this will be in the GitHub, for those who want to know. And if you add another 65 in here, it's smart enough to know that it'll keep track of that total. So let's add 2 more in there, so it knows that there's 2 more different 65s. So if I did this right now, it should say that there's, 10? Well, no, I'm sorry, 8. 1, 2, 3, 4, 5, 6, 7, 8, or 9. I was wrong. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So now it knows there's 9. So it's always going to keep track of whatever number you put in there. And that's useful because when you're actually creating a map, which I'm going to try to do probably toward the end of the series, is create a game where we can use the arrow keys or maybe even the Xbox controller or whatever to move around on the screen so we can have a little demo of a map. I just wanted to show you this as a fun example. So I hope you guys enjoyed this tutorial series, and please like and subscribe, favorite this channel. I have to cut this off because I'm running out of time. Please share this video with your friends if you enjoyed this. I'd like to hear your feedback on this as well. Any suggestions, if you come up with your own program, any questions you have, let me know. And as always, if you're interested in me going through these books, go ahead and hit that like button and, help me build my subscriber base by, becoming a subscriber if you haven't already. So I hope you guys enjoyed this video, and let's remember to keep the word great in the Commodore 64. Have a good day.